Today's video, it's all about machining this angle plate. So what I'll do, I'll show you some of the good points, how they turned out really well, and some of the defects. So this part here and here, that's the parting line I had to dig out. They come out very clean. But this is the defect I'll show you. Here it is here, and I'll probably get a close-up for you. But what happens is, this is a flat area, and if you ram too hard, silica sand expands very quickly in a certain range, and the mould tends to move, and you can see along that line and there. It's also on the other side as well. So I have to machine off a little bit more. So what happens is, when you get a flat area like that, you have to ram a lot softer. That cures that problem. Or you can put flour or other combustibles in the sand so it allows the sand to expand when heated. So here is the close-up, and you can see it's there and there, and what that comes under various names: buckles, rat tails. I call them earthquakes because their sand expansion there leaves a mark in the sand. So you're wondering how deep that is. From there to there, it's probably about 1/4 of a millimetre, maybe even 1/2 a millimetre difference. So it just means you have to machine a lot more off that surface there. It's the same with the other side. It's got the same problem. In certain places I rammed it too hard. So what happens is, you have to be very careful with flat surfaces, because the tensile forces, when they expand, tend to go along that direction there or that direction there. When you've got a curved surface, it generally doesn't happen. So here is the situation so far. I've used 2 clamps here and here. The only problem with them is they don't go all the way to the end. So this end of the casting may move. So I'll put the stop on there and a stop on there. And what I'll be doing, machining this surface here first as a trial machining. I never intended to machine these surfaces, that one and the other side as well. This cutter here is a bit blunt, but we'll see how we'll go when we mill this surface here. So this is the first pass. It's exactly 1/2 a millimetre, so it's all a good surface all the way along. Now I'll just go along the other side and trim it to match. This is the second pass on this side, and like I said, it was only 1/2 a millimetre. It's come out absolutely beautiful. The old disc brake rotors can make some really good machining cast iron. So what I'll do now, I'll go to this side and do exactly the same as this side. I'll mill along here and clean that edge up. Now I'll have a look at that surface we've just machined. Yep, it's come out really clean. Shaping up to be very good cast iron to machine. So I've got the angle plate all set up. It's all clamped down. Real horrible looking mess, the clamps. But I couldn't really figure out any other way of holding it down. So we'll go around. You can see right at the back there, there's all these stops I've put in, so the casting hopefully won't drift, which is the most important thing. This is the first pass. It's 0.5 of a millimetre, it's not much, but where the gate is, there's a few depressions in there from shrinkage, so I'll have to probably go another millimetre to completely clean the casting up. So far the casting is held, it hasn't moved, which is great. There's the second pass. So it's a total of 1 millimetre. It's cleaned up that gating area there. So now it's a long hard haul to get the whole lot done. Because this is a cheap Chinese milling machine, you can't push it too hard, so it's going to take quite a long time to do each side. Here we are, we're almost to the centre. Now what's happened here, we've got a bit of a depression here. This sometimes happens over this whole big area here. They tend to buckle a little bit in the middle, so I just have to go a little bit further to take that out. And you can see there's a little bit shinier there. When you take light cuts with the cutter, it's hard on the cutter. You've got to get underneath that scaly skin there to get a better cut. I've reached the halfway point. This is one half of the surface plate. It's been machined, but there's a bit of a problem here. This cutter was fairly blunt, so I tried to resharpen it by hand. You shouldn't do that because you should use a tool and cutter grinder. It doesn't give a flat surface. So what's happened is it's given these little dips and rises in there. So what I'll do, most of my cutters are fairly blunt over the years of use, so I'll try this one here. That hasn't been sharpened, and we'll see if that improves the situation and get a flatter surface. So I've taken 2 passes here. I can still feel a bit of a ridge there. So what I might do is I'll go along that ridge and put the cutter along there and see if it trims a little bit more off it. Oh yeah, that feels a lot better. Very smooth. So what I'll have to do, I'm up to here, I have to come all the way along and then go back again to go in the middle of the ridges and take them off so it's reasonably flat. If you're wondering why I'm not filming while I'm using the milling machine, the cutter's going, well, from here to all the way to there, it takes 8 minutes to do one cut. So it takes a long time, and there's no feed in this machine, so I've got to use hand power, which makes my hand very sore. Finally, I've got one side done. Now it's fairly smooth across there, and what I've done, I've put a ruler across there, and across there, and it's pretty flat. It's amazing really, considering these milling machines are really cheap and nasty, but they do the job. This is how I'm going to set up my angle plate to make sure it's exactly 90 degrees to my milling table. I'm using this V block and I've checked it with a square. It's very square, 90 degrees, and hopefully it should work, but I'll check it again when I do the last finishing cuts to see if the casting has moved. The angle plate's all been set up for the last face to be machined, but just out of idle curiosity, I'd like to ask, can anyone think of a different way of mounting and clamping this angle plate to the table? As I don't have a good milling machine vise, just wondering, how would you do it? Put it in the comments. So what I've done, this is the second face. I've gone all the way around and established just how much I've got to cut off and where the uneven spots are. So now I'm at 0.7 of a millimetre just here, and I'll go and do the cuts across like that until I come to there, and we'll see what happens there. Here we are, we've machined the last face. So what I'll do, I've got the square on there. I can just feel it starting to stick there and sticking there. So what happens is we've got some high spots in there and it is very close but not close enough. So what I'll have to do, we'll have to use a file and a scraper and take those high spots off so it makes it absolutely square. If I try to correct that with the machining, this machine is not 100% accurate, and I can raise it and lower it a certain amount, but it's just too much trouble and it probably won't work. I know someone's going to ask me, why didn't I use a fly cutter to machine the two faces? Well, two good reasons why I didn't. This is not 100% secure. So when I use this cutter, it's got 4 teeth, so it cuts very easily, but I still had very light cuts. The second reason is if you use a fly cutter, it's like a small hammer pounding away. This machine is probably not really strong enough to do it, and it'll flex. And with this combination with this setup, it's not 100% secure, so I don't want to invite a lot of trouble, and if it comes undone, well, you'll know what'll happen. It's a disaster. This milling machine was probably owned by at least 2 people before I purchased it at an auction. And let me show you what the previous owner went and done. They've scratched out the word there that says milling machine. So I'm betting that it is precision milling machine. So someone had a sense of humour there and thought they'd go and rub it out. And I was quite amused when I got it. But this machine might be rough and tough, but it still works. You just got to work within its boundaries.